Yeah, thanks, Tim. Thanks for your introduction. And my name is Meng Zhong. That's my Chinese name. And you guys can also call me Jeff. And I'm from the Nanyang Technological University, Singapore. And there's a blockchain center in our university. I'm doing a PhD under it. And I'm doing research on crypto finance. And I was also doing high frequency trading on the blockchain previous time in the industry. Yes, and so today we can learn together. For me also, because it was a very long time from the last time I was looking into how the blockchain is working actually. So in most of the time while working on the top, but for the most deep bottom things, uh, we should review it frequently, I think. So let me share my screen. Oh, team, I think I need to have the co-host authorized.
I gave you.
Cool, cool,
Okay,
cool,
now
cool,
you
cool.
are a
Next.
boss here.
Thank you. And yes, could you share my screen? Here are some slides. Yes, so this is the first course about how blockchain is working. So today I'm mainly talking about how the first blockchain, the Bitcoin network, is working. And the next course will be focusing on the first Turing complete blockchain is working. So as from the name, you can differentiate that the first blockchain, the Bitcoin network, is only for transferring money. But for the Ethereum blockchain, you can actually do anything on it. I mean, deploy the script or programming on it. So that's the difference. And let's start. So this is the table of content. You can see that we are mainly focused on in detail or technically how the chain is working, but I will make it understandable for the newcomers, uh, easy to understand. And I'm gonna mainly illustrate by using a demo, which is prepared by some other guys, which is very fantastic for the newcomers to understand because it's a lively demo. Yes, and um, at the beginning, some very brief introduction of how is the blockchain is. Uh, okay, from the name, you can see that blockchain is like a chain block, right? So what is inside the block? So actually, it can be anything inside the block. The block contains some information and how the information is contained and how the information is chained. It's like you put some information in the first block, and then you use some way to get the fingerprint of the first block and insert in this fingerprint to the next block. And then for every block, it will contain some part of the information of all the previous blocks. So that is why we call it the blockchain, because they are chain each other self-contained. They are self-contained. Yeah. This is how the block is chained. And another thing is that there are a lot of blockchain, right? There are Bitcoin blockchain, there are Ethereum blockchain, and now there are Solana, Sui, Algorand, Cardano, a lot of things. But they share the same logic. Okay, they are all constructed by different blocks. And the difference is that one thing is that the Bitcoin blockchain is only for transfer money, and the Ethereum blockchain is for programming on it. And then now we are actually at the third stage of the blockchain. Now the blockchain, we want it to be more scalable, faster, and can interact with each other. Like if you have some money on the Bitcoin blockchain on your address, and you want to spend this money on the Ethereum blockchain, and at this moment, these two blockchain need to be connected to each other so that your money on the Bitcoin blockchain can be bridged to the Ethereum blockchain. And the same logic could be applied to some other scenarios, like if on the Ethereum, you have an application and you want your application can be interacted with some other programs on some other blockchains. So in this case, you want these blockchain can be bridged with some sense, right? And also the Bitcoin blockchain generates one block every about 10 minutes, which is very slow. Think about the case that every 10 minutes you can write something, write some content on the blockchain. So it's not efficient and it's very expensive. And for Ethereum, it produces a block every 12 seconds, which means that you can write your content, do the transactions on the blockchain discretely every 12 seconds, which is also very slow. Think about the case of a Visa or the MasterCard. They have a payment system, right? And they accept the payment transfer, the request all over the world every second. And so every second they need to process a large bunch of information. So even this very old system perform better than the Ethereum blockchain. Then people are thinking about this question. We need to make the Ethereum blockchain faster and scalable because the scalable means that every second you can process more information, right? So it's actually consistent with the speed need. So that's why there are some further other blockchain like Solana. Solana produce block every 200 milliseconds. So it's much faster than the Ethereum blockchain. And also for some other reasons like securities. But here, mainly people request or people's need are from the speed, scalability, and interaction. And then we go back to the Bitcoin blockchain. Yeah, so the blockchain provides you hardware that you can transfer money, right? And to secure that, this system, we call it decentralized. And you may heard of some terminology that which is called distributed, like distributed computing. So what's the difference between distributed and then decentralization? So this is a critical issue actually. So here we see without the central authority for the blockchain, it actually means the decentralized. Think about the case of the AWS or the Google Cloud. They have many uh, computing center right around the world. They have a server center in the United States, in Europe, in Asia. So we can see that their computing resources are distributed all over the world. But as they are controlled by one authority, we cannot say it's a decentralized. Decentralized means that all the resources are distributed, maybe geographically, but at the same time, they need to be controlled by different authorities, or there's no um, dominant authority can control most or majority of the authorities. So in this case, we can say that this system is a decentralized system. And the blockchain is actually a decentralized system because think about that there are 100 nodes or 100 server, and these 100 server all have a record of the transaction history. So if any one of the server has the wrong recording, because another 99 server has the correct recording, right? So in aggregate, we still have the correct history, right? This is the very naive interpretation of how the decentralized design can protect um, people's security of the transaction or the content of the transaction. Yes, and let's move to the yeah next page. Yeah, and a transaction, as I said, the Bitcoin network only is for transaction, right? It's not for content. It's only for transaction. So for transaction, it means that if I want to transfer you some money, there will be two requests or requirement um, for this transaction. One is that this transaction could not be easily changed by some third-party people. And the other is that um, this transaction could be verified, which means that it can be proof that it is truly me spend the money, not the others. Okay, and the BTC network actually successfully solved this problem. And so let's move to the part that how the Bitcoin network is working. Um, yeah, I think from this moment I'm gonna shift to the demo. Okay, not depending on the on the slides. Okay, the demo is very good. And yes, before anything, before we walking into the mechanism, I need to explain one thing, the hash. So the Bitcoin network is using SHA uh, 256 hash. The 256 means the length of the hash. So if you search on the internet for this hash, it will give you a brief explanation. Hash is actually a method that will provide you the fingerprint of some information. And you can understand it that you are actually extracting some core information from a large bunch of information. Okay, and here is an example. For the input, this word, L state, you can get a hash in this format. And the SHA 256 means that you have result hash in 256 bytes, this amount of the memory or the length. Okay. So you can understand it as a one-way mapping of information. It's a one-way mapping only from your original information to uh, you can see the random combination of word. Okay. Not actually random, just seems random. Yeah. And I think you can search for this demo. The link is Ender Brownworth. Okay, if you search in your browser something like a blockchain demo, yeah, you can find it and you can play it as I explain. Okay, and here is the window we can play with it. So if you input some data, like I'm gonna input my name here, Jeff, and then here is the hash accordingly. So this is the fingerprint of my name. Okay, this is and remember it's the one-way conversion, because if I input more information, you can see that the length of the hash will not change, which means that in this process, we actually discord, uh, we threw out away some information. So only part of the information will be contained in the result hash. Yeah. And you can think about it, we are actually constructing one block, because remember that one block is actually containing some data, and the hash is the fingerprint of the data inside one block. Okay, and then let's see what the block looks like. Think about the case that we're operating on the first block, and we input some data like my name and SSS, some content, random content. And then the design of blockchain is that we need to find out some certain number and add the number into the data, combine them together, and then convert the combination of data to the hash. The hash should be begin with some certain number. Here, we only accept the hash begin with 4 zeros, which means that we need to do a try and fill in the loop to find out the nonce. It's like if we input one for the nonce, and the nonce together with data produce the hash begin by 0A something, which is not what we want. We want the hash begin with 0000. That is what we want. And this design is useful, and I'm gonna explain to you how this kind of design would be used further later in the lecture. And this mine actually provides a way to figure out what the nonce should be, the nonce number should be, so that we can get the correct hash. So here we click, and we can see that the nonce should be 27372. So it's actually a very big number, and your computer can figure it out very quickly. And we usually heard that some people are doing Bitcoin mining, right? And there are some um, mining factory around the world. So how they are mining, what they are doing for the mining, they are actually computing the nonce. And at the time we are computing the nonce, you figure out the nonce, you have the power to produce the next block. And I'm gonna talk about this later, how different nodes around the world are competing to compute the nonce. Okay, but remember at this stage that if we are working on producing one block, it's actually consists of three parts. Okay, the first part is the data. This is a necessary one. And the next part, the second part is the nonce. And the third part is the hash. Okay, we want the hash to be converted from the data combined with some sort of nonce, and then the hash to be begin with some certain number like 0000. And this certain number could change as the blockchain is evolving. Because as you can see now, here you can search on on your browser the Bitcoin blockchain explorer, and you can see some information like I'm gonna type here Bitcoin Explorer and search, and there are many Explorer, and I usually choose this one. You can see that 3 minutes ago there are new block which is mint by YBTC. This is a BTC builder, and inside the block there are 2052 transactions, and you click the height, you're gonna see that the block hash begins with very many zeros. And because the number of zeros here is more than four, and the higher restriction you put into your computation, the more difficult your computation would be. Okay, which means that now the difficulty of getting one block is far more difficult than the case in the demo. In the demo, there are only four zeros, right? But currently in the raw case, there's a lot of zero. So now it's very difficult. But if you okay know this how the blockchain is working, like 16 years ago, you're gonna very easily to get some Bitcoin by just mining to produce some block. Okay, this is the second step, how to build a block.
Mm.
And
And we
then
have a question. We have a question in our
cool, cool,
chat,
cool.
so I will read it
Oh,
out loud.
yeah.
Michael is asking, why does the hash have to start with 4 zeros in the example? What is the purpose of this leading string of zeros? Why does mining a new block have to be difficult?
Good question. Yeah, good question. So the hash start to be zero because this is the logic of the economic logic. From the economic sense, if we want the network to be secured, okay, we need to make the attack to be costly, okay, and to make the attack costly, we need to make the producing process of the blockchain costly, right? I will explain to you later why and how they are working. And because they are costly, there should be some way to make it costly. And the way to make it costly is to make the computation resource costly. Okay. And how to do that? You need to put some restriction into the computation. And the more restriction you put into the computation, the more computation resources you're gonna need, and then it becomes more costly, right? Think about the case that you are solving a mathematical problem, something like an optimization problem. The more constraint you have, the more difficult you face to solve the problem, right? So the same question here. The more zero there is, actually, the more restrict, the more condition you need to face when you are calculating the problem. And when you are figuring out the hash, you are actually doing a try and fail. Like I tried nonce one, try nonce is equal to two, three, four, five, six, seven. Okay, you are doing try and fail in the loop. Okay, and if you put more restriction, actually your searching space would change and it becomes more difficult. And yeah, so the main purpose of doing this is actually to make the computing process costly. Okay.
I think it will become more clear once we discuss proof of work consensus mechanism. So then it will become evident why we need this
Yeah,
computationally costly
right.
uh, procedure. Yeah, we will see it later.
Yeah, exactly. So later when we are talking about how different nodes are cooperating with each other, it will be clear. Yeah. But the purpose of doing the this 000 is actually to make the computation um, costly. Yeah.
And this number of zeros, by the way, is it increasing? So do they add from time to time new
Yeah.
zero?
Right.
Uh,
It's
just to
increased.
have so there are new participants, new miners. So basically more computational power is involved. But what is the purpose of adding extra zero to this like a task?
Uh, yeah, there will be more zero as the blockchain network is evolving because this kind of role is writing into the protocol, the Bitcoin protocol. So the increasing is like and depend on the total number of Bitcoin released to the ecosystem. Okay, and this kind of thing will also depend on how many people are using this kind of network, because there are two different angle. Okay, looking into the same question, and I think your another question is the zero, right? So the same, right? So if you can try this, I think. You can write a very simple Python program to say if you want to figure out the certain hash begin with some certain number like zero, the more zero you include at the beginning of your hash, actually the more time you spend because you need to try more numbers in probability. Yeah, so it's about to let people consume more energy, yeah, to make things more costly. Yeah, the zero is just like not, a setting. It can be 1 1 1 1 1 or 2 2 2 2. It can be some other numbers, but for simplicity or it's like a mutual agreed things. It designed to be used begin with zero. Yeah, can be some other number. Yeah, and then let's go back. So just now we talk about how the one block is produced, right? And then we talk about how the blocks are chained to each other. As I have talked about that in the slides, the current block will contains all the fingerprint from the historical blocks. Okay, so think about the case that we are making the first block contain the data of my name, Jeff, and then we find out the hash. Okay, and then this hash of the first block gonna be included at the header. You can think about header as a title or something, some information. These hash will be included in the content of the second block. And the in this sense, the second block contains four parts of data. Okay. One is the data itself. Here I gonna say team. Okay. The second block is for team. Okay, team is the first part of the data, and the second part of the data is the nouns. Okay, and we need to figure out the nouns. And the third part of the data is the hash from the previous block. Okay, and then the hash, and then we need to mint. Okay, here we figure out the correct nouns. Okay, and then for the third block, it should be the same. And because we have already included the hash of the first block into the second block, right? And now if we generate the hash of the second block hash has already contains the information from the first block. Okay. And then the third block is for Anna. Okay. Okay. And the same logic, we mint. Okay, we mint. And we also figure out the nouns. Okay. And things is working like this. And why we need to do it? Why we need to do it? Then we jump to the distributed uh, system design. Okay. Distributed, as I talk about, is different from the decentralized. Okay. So, but here, distributed means that there are three person doing the same thing. Okay. They are maintaining the same blockchain at the same time. Okay. For example, for all of the three person, for the first blockchain, for the first block, the content is my name. Okay. And then we mint. Mint. Okay, I think that's there's some problem. Mint. Oh shit. And see that space will also be accounted as some content. So we need to take care when we are input data into this. Make sure there's no space between your data. Okay, then we can say that for the same content, we compute the same nouns. As a result, we have the same hash. Okay, the same hash. Okay, and the same nouns. And also for the second, we have team. Okay, we do the same. Think about there are three persons doing the same thing. Okay, we have the same hash, right? Same hash. Yeah, and also Anna. Mint. 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 Yes. And then there are some properties we can say from this process. One is that because now we have three blocks for all the three nodes, right? And um, if we store the information in all of the three nodes and we treat the aggregated version of the information to be the correct version of the information, there will be some thing like if more than a majority of the information provided across the three nodes, then we say that this kind of information would be regarded as a correct history, which means that if here Anna is wrongly recorded as N, and there will mint, we can see that the result produced by the first node will be different from the other two. Okay. And then at this moment, the first node is doing some wrong thing. Okay. He's producing some wrong block. This is the one scenario. And another scenario is that if the first pair, first node contains some wrong history, like is wrongly contain the data in the first block, in the second block, and the third block. We can say the third block will have the different hash from the other two. Like the first node will have a hash begin with 2B, right? But the other two we have the hash begin with C9 something. So to compare whether the hash provided by one of the peer is correct for all the history, for all the blockchain history, we only need to compare the current hash of the current block. We don't need to compare all the history because the history is complex, right? We only need to compare the hash because the hashing process is the one-to-one mapping. There's no case that uh, two different kind of content will generate the same hash. There's no such case. So that's why we can do this. And this is the how the system is distributed. And then we move to the case that the data content is the transaction things, which is transfer of some money. Okay. Here is the case. Okay, so for the first block, uh, from Darcy to Bangley, his transfer $25. Okay, it's just like from Tim to Jeff, his transfer $25.
Let's go the other direction.
Yeah, yeah,
And
yeah,
also, I wanted to ask you a question about the previous example that you were discussing there,
yeah,
because I think you were covering very important moment when there can be, in principle, disagreement between
right,
different participants here, peer A, peer B.
right.
So this disagreement what is the source of this disagreement and what could be an example of such a disagreement? So it seems like from time to time, in principle, we can have a situation when we are not sure which history is the correct one.
Yeah,
Is it so? And my related question is, what is actually a fork? So there is a term fork,
hmm,
and for me, it seems like it is related when we are not sure which history is correct. And basically, sometimes we can even make a decision on a network scale that let's agree to disagree. So we do not know which history is correct. You can accept one or you can accept the second one. And in principle, There can be a division of network. So could you expand on this a little bit?
Okay, yeah. So you're talking about the hard fork, right? And when is the case, or what kind of case should be there that the validators or nodes doesn't agree with each other? Yeah, there are many cases like that. Here the Bitcoin um, I think the one example which is famous is the Ethereum. Although nowadays Ethereum blockchain is working in the theme of proof of stake rather than proof of work, but at the beginning it works in under the proof of work, similar with the case of the Ethereum blockchain. So when I think that the Ethereum blockchain started at 2014, right? And in 2015 or 2016, that blockchain was hacked, and that is a huge amount of money from the Ethereum Foundation, I think. And then some of the nodes think we need to go back, actually cancel the block with the hack transaction. But some other node disagree with that. They say that we need to include it because we are decentralized designed. So there are two groups, right? One disagree and one agree. And those nodes agree with the point that we need to delete this transaction constitute our current Ethereum blockchain. And the group of nodes uh, doesn't agree the point that we need to delete the transaction forked to another blockchain, which is called the Ethereum Classic. So you can still find out the Ethereum Classic, which is still working uh, under the proof of work. And yeah, this is the very famous hard fork. So hard fork happens when there are something that a large majority of the nodes agree with something, and the other part of the nodes doesn't agree something. And if you agree, you need to sustain your argument, which means that you cannot shift to the other part or change your history. Because you are hard forked, you are into the different road. Okay, so this is the case, and yeah, I think hope I answered your question. Yeah,
Yeah, I think that we can ask them to in their take-home assignment to elaborate a bit hard fork of Bitcoin, because as far as I remember, there are two versions of Bitcoin actually,
you
Bitcoin
mean
Cash
Bitcoin?
and
Oh,
Bitcoin.
yeah, Bitcoin
So
Cash.
yeah, I think we can ask them about how it happened and what were the details. Okay.
Yes, exactly. Yeah.
Yeah. Okay. So let's go next.
Yeah, so let's move to the transfer of contents. Yeah, so that is what is doing by the Bitcoin blockchain is for the purpose of transfer of money. Okay, and then okay, my transaction was deleted. Okay, let's say team is transferring me $25. Okay, and then I mean this block. Okay, it spends a lot of time. Okay. And then I got a hash, and then I put this hash to the header of the next block. Okay. Because the only thing I changed from the previous page is that I replaced the content of the data with some transactions. So the other things would be the same. Now we are transferring money rather than recording something as the data in each block. Okay, so the logic is the same. But the only thing that we need to care about is that 2 points. Okay. One is that the money will not generate from the air. We need to have something, or we need to have a mechanism to generate the money. And the mechanism is that every time a node successfully compute the nonce, which means that he successfully mint the hash and produce hash firstly in the network, he gonna be rewarded with some money. And this rewarding transaction would be put at the beginning of each block. And I'm gonna show you this kind of thing in the next demo. And another thing is that because inside the content of each block, the data content is a transaction rather than a balance change. So if you want to say your balance, your current balance, you need to actually download all of the history of the transaction. Then you can calculate what's your balance. So it's different way of how we record the things in a balance sheet or something. Okay, in the balance sheet, you are recording the balance of each person, and if some transfer is happening, you are deducting some certain number to some certain person, and then add some certain money to some certain other person. But here we are doing the transaction. Yeah, two things. And then we move to the next demo. So in this demo, actually we see that where the money comes from. The money is actually from the system, and you can regard the system as a god. And that's why it's called a mining. I think the word is very good because as we say that we mine like a gold in some mountains. So the gold is actually given by the nature or given by the God. And here, same thing is happen. If we are calculating the nonce, we are the miner on the blockchain. The money is actually given from the nature, from the system. Okay, so every time if Ender is the peer, or we say peer A, if peer A is among the first person successfully calculated the nonce, okay, here the nonce should be full one something, then he gonna be rewarded with some money, okay, with 100. And in the next block, only he has a balance to be spent, okay. He can spend like his money while the transferring this money to some other person, right? And then we mint. Okay, so this is how the Bitcoin can be generated from the process of mining. Okay, yeah, and this is the first part of this demo, and you can actually watch this video. There is two video. There are two video. The first video is discussing this first part of the demo, and the second part is about some other things. It's about how your transactions would be protected by the cryptography design. Okay, so as you can see that the first demo, as I illustrated just now, is made about how the system is designed to be distributed and why it should be distributed. The distribution protects your data itself, okay? Protect your data that cannot be easily changed by some third party, okay, from the malicious attack. And the second part of this demo is actually showing how your transaction could be protected, okay, how to show that and because if every transaction on the blockchain is just a recording of the transaction, then I can see that team transform me 100 and I produce the block. Even without the agreement from team, I can steal his money. Okay. So in this way, his money is not protected. So the second demo is actually illustrating how your transaction will be protected by the cryptography algorithm. So to illustrate this, okay, we need to know the relationship between the public key and the private key. Okay, this is also a one-way mapping. Okay, one-way mapping. Um, the private key is a context in certain lengths. Okay, you can make it random, or you can type by yourself. Like I want to make my private key from the beginning of the certain paragraph in certain book. Okay, that gonna be a very good idea for you because you don't need to remember the content of your private key by yourself. You have something to help you. Okay, but we can also randomly generate some private key. And at the same time, you have a public key. Okay, only your private key can generate your public key, but your public key cannot reversely generate your private key. And the public key is actually the address we talk about on the blockchain. On the blockchain, you can usually hear that somebody will have some certain address, received some money, or in some news, I think it will say that we successfully find out the address of certain hacker, like previously in some. If you heard the news that in the middle of this year, a very big exchange called Bybit lose money because of the attack from the North Korea. And very quick, a third party investigate this case and release the address of this hacker. Okay, the address is actually the public key generated from this private key held by these people. And once the time you release your private key to some other person, then your money in your wallet will be stolen because of the process I'm gonna introduce to you later, the signature, the process of signature. Okay, so this is the all about the cryptography. Okay, so here if I input some content into this algorithm, so let's think about this website as an algorithm. If I put Jeff and then I use my private key to sign this information, I can have a signature of the message, which is the encoded version of the message, because you can see that this message seems to be a random combination of numbers and characters. And then because I have the private key and some other person can see my public key, right? So some other person can verify my message, use my public key. It's like to verify whether this information is sent by yourself. If it is sent by myself and signed by my private key, then you can verify this by my public key. So if you push this button, you can see that the signature together with the public key is consistent with the message. Then it means that this signature is signed by the private key generating this public key. Okay, then this is actually a very strong proof, which proves that only one person sent this message, which is me. Okay, I signed this message and generate the signature. Okay, so this is a process of signing something, some message. Okay, so if we sign our transaction, things can be working. If we sign our transaction, we can say that if some other person have my public key, he can prove whether it is me spend the money, whether it is me doing the transaction. Okay, then we can see that in the next demo, we see that if I send some money from one address to address, okay, so the first one is my address. Okay, begins by 045, and this public key or address is actually generated by this private key, because I can only spend my money, right? I can only spend my money, so the money could also be transferred from this address to some other address. Okay, and you can see that from the key, the public key is begin with 045CA something, and in the transaction, we'll actually transfer money from my address to some other address. and I sign it, I got a signature, and some other people can verify whether this transaction is actually conducted by myself. So I verify. Then a green color, which means that the signature is consistent with the message, which is the transaction. And it means that it is me, okay, send the transaction. And if some other person want to change a message, like uh, to send to like he want to change a message to I'm sending some money to some other person, and after simply change this information, and then some third party, some others, some even others verify this information, we will say that this is inconsistent with the signature generated by myself. And because only the private key can generate the signature, so the third party, the others, cannot use the transaction information, the message itself, to generate the signature because he don't have my private key. And that's why I told you at the beginning, if you release your private key to some others, your money will be transferred to some others. You will lose your own money. Okay. Yeah, this is how the transaction will be signed. And then for the blockchain, it is the distributed system, right? And we can see that there are three-person doing the mining, and let's see, let's start to work on the first page, for example. Um, if if the peer A you have this private key, okay, have this private key, and he get a mining reward of $100. And if he is very greed and he want more money, and he just simply change the number that he got $110 from the nature from his mining reward, and he meant the hash would be different from the hash, okay, calculated by some other people, okay, because this transaction is done by the nature, and the peer A doesn't know the private key of the nature. So even if he changed this one, it does not work. Okay. And things also for the case for the following one. Okay, if there is some malicious work attack, right? If someone is changing the amount here in the first transaction in the second block to 100, and then we can say that the signature becomes red, which means that the signature is inconsistent with the transaction information. And also, even if we mint, the hash would be different. Okay. And if your transaction information is inconsistent with the signature, we get a different hash, right? And then we know that this block contains some wrong information. Okay, so in this way, you can protect your money from being spent by some others. Okay, only yourself can spend your money. Okay, this is roughly how the blockchain is working. Um, so at this point, is there any question? Okay.
So yeah, I would ask. So basically, when we are as a miner, we want
Yeah.
to have a right to write the next block, to create the next block. So we do not actually check any transactions inside this block. So they are already uh, they are already valid because of these cryptographic signatures. Is it correct?
Yeah. Right. Yeah,
But
there will be usually there will be a pre-check because this check of the transaction I think will be done before submitting the calculation of the block. So there will be some round of check, yeah, before the calculation. Yeah. So in Ethereum blockchain, it's a more complex before the time. There will be another authority is doing this to check the validity of the signature, and also for the Bitcoin blockchain. So although they are all done by the builder, but the builder have a different algorithm to check it. Yeah, yeah,
Mhm.
they will check it. Yeah.
But the question is the following. So if all these transactions that are going to be included in this block, they are already valid, why we would need such a complicated consensus mechanism then? If everything is there, is already correct, let's just write down and that's it. Why we need to compete and make this process of creating a next block that will include these transactions so complicated and so computationally expensive?
Okay, so let me think. Um, so doing the signature is actually protecting your money from being spent by some others, right? And but you can spend your money, right? And if this system is centralized and you are controlling this system, you can actually doing the double spending, which means that you can if you have only $100 in the system, but because you are controlling the system and you have your private key, you can transfer me like $100 and also transfer Anna $100. Okay. And but in a distributed system, because all the transaction history is recorded by different person. Even if one person is doing this, some other person is disagreed with him. So that's why mm, we can avoid this kind of situation. So they have actually different purpose. So the distributed design is actually prevent people spend his money multiple times. Okay. And the second thing, the signature is actually prevent your money to be from being spent by some others. Okay. Yeah, we have some question in the chat box. Okay. So where does the program get the money? That it distributes among miners later down the line. Okay, so this question asks where the money comes from. So the money actually comes from the reward. So every time, so how? Okay, so let me explain more detail about how each block is mint. Okay, so let's see this website. I think this website. You can see that each line, each row is the information of a different block, right? And the different block is actually produced by different miner. And during the time between each block, people are computing the nonce number of the next block, right? Because all the transactions are actually from the mempool. Okay, so here's the mempool. So the process is like the users submit the transaction to the mempool, and his transaction will be waiting in the mempool. Here's the mempool. The unconfirmed transactions. Okay, there are a lot of unconfirmed transactions. Okay, and all of the uh, all of the builders will extract unconfirmed transactions to build his own block, and then they will calculate the nonce. And the one who firstly find out the correct nonce, which is the correct means that the hash should be begin with some certain number of zero. The first one get this hash will have the power to produce the next block, which means that his block will be included in the blockchain. So in this sense, you can say that different people, different builder may have different block structure. Okay, so that's why the users will sometimes increase the gas fee of the transaction. The gas fee is the a payment to the builders. Okay, it's like if you use the Visa, you need to give some service fee, service charge to the Visa company. So here is the same. If you want your transaction to be executed early in time, you need to you want to prioritize your transaction. You need to give some priority fee to the block builder. And then the block builder will have the incentive to include your transaction firstly or have some priority compared with some other unconfirmed transaction in the mempool. And then your transaction will be included by most of the builders in their block, and then they constructing a block. Okay, so in this way, you can say that different miner actually is building different kind of blocks with a different combination of transactions. And then all of them are computing the nonce, okay? And once they are computing the nonce and the win, like which I means the first one, okay, first one successfully find out the nonce. Because his transaction will be included in the blockchain. The first transaction of the blockchain would be the Coinbase transaction. So here in this demo, you can see that for every block, the first transaction would be some transaction from nowhere to someone with a certain address. Okay, so this is the way. So this is the transaction I talk about. I just say uh, someone is rewarded from the system or from the nature. Okay, so it's just like a transaction. And all the money circulating in this system is from the rewarding. Okay, so this is what we can see from this system. Yeah, so hope I answered your question. Yeah. Yeah, so if there's no other question, maybe we can continue with my slides. So this is a demo, or the demo, and if you if you want to review the things, you can also see the watch video. Okay, we have some. Oh, okay, thank you.
Yeah, we will send the link to this resource via
Oh,
email when we will send out the next assignments.
yeah, sure. And then we continue on our slides. Okay, so as I talk about, when you want your transaction to be executed, you submit your transaction to the mempool, and the mempool there are a bunch of unexecuted transactions with it. Okay, and all of the builders will be selecting the transaction from the mempool and build their own block. And what is block? Okay, now you are clear, right? You are clear. You know what is a block. A block is a bunch of transactions, from one address to another address. Okay, and like a page of ledger. Okay, this kind of sentence is actually tricky because it's not like a general ledger. A general ledger is actually describing the balance change. But now we are not describing a balance change. We are describing a transfer of money. Only after accumulating all of the transaction, you know how much of the balance you have, okay, on your book. Okay, and then let's move on. Okay, this is a block. And okay, we see that in these slides, it's very clear that the new block is actually built by using the pending transactions from the mempool. Okay. And the header is actually combine some information. Okay, from the demo, it's a simplified example of the blockchain network, but in real case, the header is actually combine the previous block hash, the road, okay, the single hash submitting all the transaction on the block. So and the time step, the difficult target, okay, so it could be the number of zeros because the number of zeros actually the difficulty level of producing the certain block and nonce, okay. And then this is the how the blocks are combined to each other. Okay. I will not spend too much time on this, because oh, I think you already know it. Okay. Why mining? Okay, so this is the one question asked by uh one of our audience, right? Why mining? Why proof of work? Yeah, so the proof of work is actually a need by the system that the transaction itself should be costly. So why is costly? So the incentive is that we want uh, the system to be um, proof from some malicious attack. And to do that attack should be costly, okay, should be costly. And to make it costly, producing should be costly because only at the time when you are controlling majority of the computation power, you are control the blockchain. And the computation power is itself costly.
And I think it's very important when you say control the blockchain, as far as I understand this, is like you control the way how the history is written. So you are actually writing history alone
Yeah.
and broadcasting this history to everyone else involved in this network. So we actually want to make this particular thing costly, to be like to have the power, computational power enough in order to be first in in the blocks creation compared to anyone else.
Yes, yes, yes. So the costly doesn't mean the broadcasting itself. It means the node you control. Like in the system you control, like in the system there are 100 nodes. So the aggregate history, we mean the aggregate history. Aggregate history will be determined by the majority of the history held by the majority of the node, right? So in this sense, if you control the majority of the node, you actually control the history. Yeah, you are right. Yeah.
And also one thing that just came to my mind is that if you make block creation process costly for any participant, what we want to achieve is that you are not superior to anyone else in the
Mm,
network in terms of this capability. So if you make it costly for anyone, it means that it will be super costly to be first compared to anyone else. So
mm, mm.
like the
Yes.
comparative costs are much higher than your kind of cost of creating block. Like comparison to others makes it super costly.
Yeah, yeah,
Uh,
yeah. You are right. Yeah. So it's equally costly to everyone. Yeah.
yeah,
Yeah. Yeah, yeah, that's why it's costly. Although it's not that costly at the very beginning. So if you participate on the Bitcoin blockchain at the very early time, like in 2008, even your laptop can mint a lot of Bitcoin because you're actually participating. You are a minter. Yeah, you are a miner and you mint blocks. Okay. So, but now it's very costly. So as you can see that at the very beginning, if there are very fewer participants and um, okay, if you have a very comparative powerful computer, then you can control the system. You can fork or doing something. But at that time, not many people are interested in the blockchain and Bitcoin. So nobody is doing that. And the Bitcoin itself is not expensive, it's cheap. Yeah. So it's like, yeah, when it becomes expensive, it becomes costly. Yeah. And then, yeah, finding the nonce. As I said, finding the nonce because the hashing is a one-to-one mapping. So if you want to find a hash with certain constraint, you need to calculate in the loop. Okay, you need to do try and fill until you find the correct answer. Okay, and the mining difficulty means that the higher constraint, the more constraint the result should be, then it becomes more difficulty. And yeah, the reward is the first transaction in each block to the block builder. Yeah, and the broadcasting is actually the way that each transaction builder, each block builder can know what kind of block is built by some others. Okay, this is a way of communicating by the blocks because they are network, right? The network needs some way of communication. Okay, then after building the block, after broadcasting the things, then the block will be included into the chain. So here the growth the chain also means that more blocks will be included in the chain. Yeah. And then we say why the blockchain is secured. Just now we talk about why mint should be costly. And this is actually an equivalent question. So why it is costly? It's costly, its costliness ensured the blockchain is secure, okay? Because attack the blockchain is very costly. That's why it's secured. But it doesn't mean it will never be attacked, right? It only means that um, attacking it is very costly. If someone is insist on attacking the Bitcoin blockchain, it happens sometimes. Yeah, so and in this way, you can check this website, which is a Crypto 51. Okay, because in the blockchain, in the Bitcoin blockchain, the integrated history or the correct history is determined by the majority of the nodes. And if you control the majority of the nodes, which means that you need to control at least 51% or more than 50% of the computing power. So you have some probability that um, the next block um, produced by you, okay, the next block produced by all of the computing power by you can aggregate together, change the majority of the history. So in this way, you can change the history a little bit. Why I say a little bit? Because the more history you change, the more nonce you need to recalculate. Okay, think about the case that in the demo, okay, here the blockchain. Okay, so in this case, okay, the distributed one. In this case, if you are peer one, and if you want to change the history, if you want to just change the latest the latest block data, like from the empty to L, you just need to mint once. But if you want to change like the very beginning data to T, like T, you actually need to mint firstly for this block and also for the next block, because the next block also contain the information of the first block and also the third block. And also the following one. So the computation resources needed to change the full history will be very huge, and the time would be also very huge. So that's why the longer history you want to change, the more time you're gonna spend, as well as the computing resources. And the website. Oh, let's check the website. Oh shit. just search, okay. Just search 51% attack cost, okay. There's a website showing the cost of doing the 1 hour attack, okay. So the 1 hour attack cost. Okay, so this cost means that if you want to control the computing power for a certain blockchain for 1 hour, how much cost you need to give out. The cost mainly about the computing resources. Okay, computing resources cost. And another thing is that if you change the history by 1 hour and then you stop changing, you stop the attacking, it doesn't make any sense because the rest of the nodes will reconstruct the history and they go back. So if you want your history to be changed permanently, you need to fork the blockchain, which means that you need to do the attack all the time, which makes the attack unprofitable, okay, some sense. And why it becomes unprofitable? Because this kind of attack only applies to double spending, okay? And if you don't have much money at the very beginning, the, how could you make very huge profit in this kind of attack? You cannot spend some other people's attack money because you don't have some others profit key. So that is why the Bitcoin blockchain now it's very difficult to be attacked because the attack cost is very huge. But for some small chains like the Dash, because the attack cost is very cheap, so it can be attacked. But there's another problem raised. Because it's very cheap to attack, also means there are nobody using this blockchain. So also you are changing the history of this chain, you get some profit maybe on this blockchain. The profit you get from that kind of coin, worseness is worseness. As a result, it's not profit. Okay. So that is how the blockchain is secured. Okay. Okay. From the attacker's perspective.
You know,
Yeah. So yeah.
I was thinking that okay, so we uh, come up with this proof of work consensus mechanism in order to make it super difficult to control the writing of the history.
Mm,
So not to letting one person. So if you want to control the history, it means that you need to be computationally superior, a lot of computational power, and this is what guarantees our blockchain from one person who does whatever he or she wants.
yeah.
The question is, um, guess the following strategy, that you just take a pool of potential people who will have a right um, to produce the next block, and you will just randomly pick one from this pool of potential how to say that, potential referees or potential, so who are miners right now, they will do the similar thing, and you just do not need any computational power anymore. You just guarantee that this person who will write history is just picked randomly. Why this strategy is not good? Randomly picking the one who will write history, because he will not control the history. Nobody will control a history if we just randomly pick a person who will write the history.
Okay, so I think I didn't fully get your question. So do you mean the builder will collude or something?
So now
Yeah.
only a miner has a right to create a block because he finds these nouns, and he
Yes.
actually he's granted a right to
Yeah.
create the next block.
Yeah.
The question is, who is granted this right? Now we grant this right to a miner, and being a miner is super difficult because, well, unless you do not have a majority of computational power, you will not be granted this right. So there is a competition between these potential people who will have a right to create the next block. And my question was, what if we just get rid of this competition and we will just randomly pick a person who will have this
Okay.
right?
Then the things becomes the proof of stake, right?
Exactly. So but in
Yeah,
proof of stake, you do not pick a person randomly, you
yeah,
assign some
it's a,
probability
yeah,
that is related to a stacking amount. So how much you put a bet, your own wealth on this process. But if we are just to come up with consensus mechanism, it seems like, well, we could just randomly pick a person. And
yes. So the things is still about costliness, right? The cost. If you just randomly choose a person in the proof of work mechanism, then the producing process is nothing but a random game. Then if you want to control the system, you just create more node so that you will be have higher chance
okay, fair
to
enough.
get it right.
Okay, fair enough. Fair enough. Yeah,
Yeah,
yeah, very good. Yeah, yeah,
yeah,
very good answer.
yeah,
So,
yeah, yeah.
just to expand a little bit what was said, that if
Yeah,
the process of is a random choosing of a participant, then we just can create fake participants and increase
yeah, yeah,
probability
right,
of being chosen in order to write history. Yeah, okay,
right.
very good.
Yeah, and you're actually bringing our topic to the next one, right? How the proof stake is working. So
Yeah, yeah,
so in that case, that's why on the proof stake, the nodes need to have staking, and once they are doing some malicious things, their staking will be slashed, which means that they're gonna cancel or delete your stake. So
yeah,
the way of punishment. So that's another way of a costly.
yeah.
Yeah.
Cool, cool, cool.
Yes. So any other question? Yeah. So I gonna summarize today's content. Yeah. So today we mainly talk about how the proof of work blockchain system is working, and to be the first blockchain in the world, the blockchain of Bitcoin is only doing a transaction rather than some other things from of the later more sophisticated blockchain. Okay, and to protect the transaction from being spent by some others, we use the signature or some cryptographic way to generate the signature. We using the private key and the proof your content is actually signed by the certain private key using the public key, right? Yeah, this is the first point. And the second point is that to make sure um, nobody is doing double spending, okay? To spend the one amount of money twice, okay? The system is constructed in a distributed way. Okay, so this two kind of design is the core things of the blockchain or the proof of work mechanism. Yeah. And yes, I think this is the main content of today's lecture. So yeah, hope you find it well. Yeah.
Yeah, I think that a good a bottom line of what you were telling us and explaining to us, thank you very much, first of all, uh, is that at least for me, the blockchain technology seems like to be a digital democracy in some sense, that we are digital democracy that we want to apply to payment system. That what we really want is to write a history of transactions together, not letting one particular participant power to control this history. And I think that this is a very deep philosophical thought, that what we really want, we want to find a way how to agree on the history without giving a right to one particular participant to be in charge of this history. It's like a way how to find a consensus. And this is what ancient Greeks were trying to do, right? And this is how they come up with the idea of democracy. Now we want to invent it, but applying to actually finance and payments. And this is great.
Yes, and this is a level of democracy, right? And this is the first stage of the blockchain. And the next stage of the blockchain, the Ethereum, provide people the way to issue his own token, which is a way of another way, another level of democracy. I think it's autonomy, right? So it's an autonomy. So you can see the development of the crypto things. It's quite yeah, it's cool. That's how it's evolving.
Yeah, cool. So any other questions? You all are welcome. We have a little bit of time before starting the AI session. And if unless there are any questions, I think that we can say thank you very much for your presentation. It was really, really helpful and very interesting. Yeah.
Yes, thanks for attending. Yeah, so I'm very happy because myself is in the crypto industry. So I'm very happy to say people are interested in this and enter to play with this. Although now the Bitcoin price is very high because but it's only a start. I think it's a start because I think the next generation is the AI generation, right? And for the AI generation, the currency for AI is the cryptocurrency. So as you can see that as the AI agent or something is more powerful, we can the the wallet used by the AI agent is the crypto wallet because they cannot do in the KYC in the back. So the only way they can spend the money is through the blockchain. Yeah. So you can see its potential. Yes. Thank you very much.